Gotta be kidding me. Stop listening. That's amazing. I know what an inductor is. They're used in transformers, they're used in switch mode power supplies. I knew they stored electromagnetic fields, but I didn't realize that they could suck metal into themselves. Holy cow. I just had this funny idea. What if you put hot glue onto this plunger and stuck that on a car dent, and then you just press a button to complete a circuit to a battery of this inductor, and that sucks the plunger away from the car. So you'd have to build a legging system on this thing, so that it has pads against the car to support the inductor, so that the inductor just doesn't suck onto the plunger part, and it's stable here. And then this will pull your dent. If you have a powerful enough inductor, it should pull the dent out instead of a slide hammer, or instead of a physically gripping something to pull. You could use pulse width modulation to affect and test different levels of pull power, pulling it slow, gradually ramping up the power versus just pulling it in a sudden jerk, and compare the results to see if dents tend to be pulled better with a jarring force or with a gradual force, and how that might impact how well the glue sticks to the dent. Maybe if you pull the plunger too hard, the glue pops off the car dent. If you pull it real gradual, maybe that pulls the glue off more likely. Maybe shocking it is better. That's why a slide hammer, it's shocking. So maybe shocking is better, but I'm not sure. But this could be really useful for dent pulling, I think. I could see how this would be used for locking and unlocking doors of a car. I could see how it would be great for turning on and off or pinching air or liquid tube. I'm guessing if you reverse the polarity of the feed, it would repel the metal? No, well, maybe it would. I'm not sure. I mean, if it can draw metal in, can it also push metal away? That needs to be answered. Otherwise, you need a spring. In this case, shown in this video, you would need a spring on the backside to push this back into seated position once you take away the electromagnetic force inside this inductor. Which is fine, but I'd just be interested to know if you could have it shoved forcefully by just reversing the polarity of the charge. My instincts tell me it probably would still just be a magnet either way. Since the metal doesn't have a polarity of its own, I think it's just neutral. I'm not sure though. That's just my gut feeling. If a solenoid's not working, it seems to stand to reason to me that it shorted out. Maybe it got too hot, and since this is magnet wire, Maybe it melted and now it shorts out and it doesn't create the magnetic field. It's just like a short circuit. That could actually burn out something in the supply motherboard as well, which is scary. Or obviously one of the wires could have just broken in half and now it's just not completing the circuit. I'm really pleased. Oh yeah, solenoids I guess are used in relays. Comments are disabled on this video. Why do people do that? You know, I just realized, what was I gonna say? Shoot. Oh, you could use a solenoid to cause two electrical contacts to come together to send something really high voltage, or even AC. So let's say, I mean, I guess that's a AC, like a relay then. I'm reinventing the relay. But what I'm thinking is, like, let's say you want two high voltage, 1000 volts, 1000 amps, something crazy, to turn on and off. Well, you can have a physical switch, but what if you want to do that electronically? Well, a solenoid would be a great way to just shove the two connectors together. Plug them in, so to speak. And the solenoid could be controlled just by a microcontroller with a battery power support or some power source and a MOSFET. And the solenoid would cause a physical connection to be made. Now, a servo could do the same. I guess solenoids are chosen because they're cheaper. It's just wire wound up in a coil. It's cheaper, simpler than using an actual motor. So I can see why people use solenoids. In any case a solenoid is used, a motor could have just as well been used. But the solenoid is just a simpler, so cheaper concept. And a solenoid would be very easy to make. You just wind up some wire. It's that easy. So, fixing a solenoid, installing solenoids, all of that will be a piece of cake. Making your own solenoid, no big deal. And now I know how a solenoid-based pneumatic system works. Oh look, there is a spring. I knew it. There's a spring here. The spring will push it back shut. They just added that in without saying what it was. So that answered my question. You do need a spring. Got it. Okay. And when it shuts, that air can just let out. Got it. Got it. Okay, I fully understand pneumatics now, guys. 100% I could build my own pneumatic systems. Holy crap, I could create a pneumatic system to... Wow, to be able to create my own solenoid-based system. That would work for hydraulics too. But there's only a spring stopping the air. So that's kind of sketchy. That'd have to be a heck of a spring, right? Yeah, what I was saying is I could use a setup like this, which would be easy to make a pneumatic dent puller. Just connect the hose to this side instead, and that will push the plunger that way. And then just have this rigged with little arms and little rubber pads to be pressed onto the car. And then as the air pushes in here, it's going to pull your tab, which is on this side, and that will pull the dent out. That, as opposed to a hammer puller, it'd be a pneumatic puller. I could just connect that to my air compressor, and this little box could just be Arduino based to send power to the solenoid. That'd be fun.